Welcome back to the space race topics. How India is going to be prepared for the future missions, the bottom line, the cost, and how India is going to line up in the future space missions, the cost, and how it's going to adopt the multiplanetary species. Let's find out. Let's find out from the vlog.
Aligning top dead center. Lower slowly.
Swing looks good. Watch the tail clearance. Bring it to vertical.
Bay is prepped. Bring in the center 13 first.
Up, up. Slow it down.
Going to the space is not so easy, and because it is hard, so it is hard to process. Let's trust the process and communicate it, collaborate it, and yeah, let's trust the process in the future missions and how it is gonna work out.
Trying to go to the moon is a much harder job than trying to go to the space station in terms of the physics of the problem. So we added a fifth segment. And what excites me about these tests is the sheer scale and the magnitude of a 150-foot solid rocket motor firing in the desert. It makes
is the target and another being the chaser. This velocity will allow the target spacecraft to build a distance of 10 to 20 kilometers with the chaser. Now this will happen within a day. Then to arrest the increase in distance further, the target will use its propulsion system and slow down. It's like applying a brake. After this maneuver is done, the target and chaser will be in the same orbit with identical velocity, not relative velocity. The distance between the spacecrafts will not increase further after this exercise, and 20 kilometers will be the separation between the target and the chaser. This is known as far rendezvous. The idea is to create relative velocity and compensate for a small portion of it. So the same technique will be used when the chaser has to dock with the target. Slowly the chaser will approach the target and reduce the 20-kilometer distance. Not at one go, but step by step. 5 kilometers, then 1.5 kilometers, 500 meters, 225 meters, 15 meters, and then 3 meters. And then the docking will happen at a speed of 10 millimeters per second. This is called low impact docking system. Once the docking is done and the spacecraft becomes rigid, electrical power transfer between the two satellites will be demonstrated. As is ISRO's specialty, the spacecraft were not built and sent for the docking experiment alone. After the experiment is done, the spacecraft will be undocked, used for their respective missions. To execute SpaceX mission, ISRO has indigenously developed several technologies. The docking mechanism, a suite for rendezvous and docking sensors, power transfer technology for transmitting electrical power, as I mentioned earlier. In fact, the rendezvous and docking will be an autonomous process. The satellites also have inbuilt intelligence to know each other's state and will communicate autonomously. The spacecrafts also have a processor to determine each other's relative position and velocity. Then, of course, there are simulation test beds for both hardware and software design validation and testing. This is a cost-effective demonstrator mission by ISRO. Why? Just look at India's space ambitions. Indian on moon, bringing back samples from the moon, and building an operation of Bharatiya Antariksh Station, and so much.
Maneuver complete. Trajectory has converged on waypoint 0.
Go over just a few of the space shuttle missions and how these pieces were put together. We've got to remember, the station isn't just aimlessly floating in space. It's going incredibly fast, about 20 times the speed of sound here on Earth. It orbits the Earth once every 90 minutes. Here's the front of the station. It always travels in this direction. So this is forward and aft, port and starboard, and then there's zenith pointing away from the Earth and nadir pointing towards the Earth. These terms are part of the regular vocabulary of an astronaut.
Close to orbital velocity, and even though both Dragon and the ISS are traveling at about 17,500 miles per hour or 27,500 kilometers per hour, they are moving very, very slow, like 1/10 of a
India all try to find water as early as possible. Otherwise, someone else find the water. They may say, this is ours. So this is where Japan and India should collaborate. You have a nice landing system, which we don't have, and we have a nice rover. This is the reason why we are collaborating intimately between JAXA and ISRO.
And why are you landing on nearer the South Pole or on the South Pole, as Chairman ISRO says?
Yes, I think there is a distinct difference between the polar region and the equatorial region. In the equatorial region, it is illuminated by heavy sunshine, and it's extremely hot, so that any form of water is vaporized. So you cannot find the water in the equatorial region. In the polar region, the sun illuminates horizontally, so there are multiple shadows by the mountains where you can find ice. That's the reason why we have to go to the polar region, which is much more difficult to land because of the multiple mountains. So the Indian technology, your mission, will bring our rover to this mountain area. Right?
Now will you hope to land at the place where Chandrayaan-3 landed, which Prime Minister Narendra Modi named as Shiva Shakti Point?
Mhm.
That's where Chandrayaan-3 landed.
Yes.
Will you look at that site or further south on the South Pole?
Both Japan and India identified a few possible locations where you are supposed to find the water or ice. And there is only 5 to 7 locations where the United States, Japan, and India identify to find the water. So it's another new place to land. But you already landed successfully in the polar region.
Yes.
So we fully rely on your ability to land on the desired area where we surely find the water, ice.
Now, on your rover, you're wanting to spend 100 days.
Yes.
The lunar night,
By
the lunar day
extracting
is
water in the
14
moon
days
is
each. It becomes
not,
very
maybe
hot.
it's hard, it
becomes very
will be
cold.
possible.
Now,
So by
without a radioactive
mining minerals
source
or
to heat
regolith,
the
it can
rover,
produce
how will
oxygen,
the
so it can
electronics and the rover survive on the
it can
lunar
produce
surface?
oxygen
I
for
think this is a
breathable
very important
for human
question. During the
habitable
night
in
of
the
the
future.
moon,
So
you don't have sunlight, so that you don't have
that's the process
electricity.
scientifically, I hope.
You have to rely on the battery.
Yes.
But it's extremely cold, below 100 to minus 100 degrees centigrade.
Yes.
So that this rover has a mechanism to protect themselves, to reduce the heat dissipation, like
So it insulates.
insulates. And
So-
there is a special insulator. When night comes, this insulator opens to protect the rover.
So the rover will have a suit or a sweater to keep itself warm.
exactly. In the nighttime, they have additional sweater to make them warm.
Now, if you find water, does that mean we can have human habitation,
Yes.
permanent habitation on the moon?
Yes, I think so. Water is really essential for survival of humankind. First of all, we do need water to live. We do need, we can create electricity from water. We can create fuel from water. There are other materials to be found on the surface of the moon. So that rather than bringing things from the earth, you have to create building and system there by moon material. That's the concept.
So India and Japan together looking for water on the moon for permanent habitation on the moon surface?
Yes. The building a facility on the surface of the moon is a really challenging, expensive job. So that one country cannot do everything. So this is where Japan and India should work together based on our experience of LUPEX.
And so far, has the cooperation been good?
I think excellent. ISRO is an excellent partner for us. They have a landing technology which is quite reliable. You had a successful landing already, so we have a full confidence on their reliability.
And will it be the most heavy rover ever to be sent on the moon with 350 kilograms?
Yeah, that is a headache. It's our rover is a little bit overweight. So ISRO is asking JAXA to make it squeeze, and they are trying to respond. Yes.
And when do you hope to launch LUPEX?
It is 2028.
Thanks a lot for speaking to me.